Hi everyone, this is Tanumoy from Cheenta. So last time we have done a problem in which we have seen that the maximum velocity that lift has achieved due to the acceleration. To quantify that, we want to find out the height of the building that in which it was moving. So to find out, we have an experiment that we will be conducting on a virtual lab, and then we will be finding out it theoretically that how the height has been measured through the acceleration quantities that we have quantified. So here we have a construction in which we can see a lift, okay, and we have placed an object inside it, and we want this lift to accelerate. So we can see that how the mass of how the apparent weight of the object vary when it is in rest frame, and what happened when it is in accelerating upwards, and what will happen when it will be accelerating downwards. So first start the situation when it is accelerating upwards. So we have developed this entire virtual thing where we have entered these thrusters to the lift. We have introduced this object with some mass, as we can see, and mg force is acting downwards, and we are sending this with the velocity. So let's see how it goes when we start the experiment. Okay, 1, 2, 3, start. So once we have started it, see it is increasing in speed, that is the arrows are increasing, and then as it moves to the highest point, the entire mass is shifted to upward direction. Now what we can do is we can take these thrusters, as it's not unidirectional, so we can take these thrusters and we can now give it a downward velocity. Okay, let's see. 1, 2, 3, start. Now see, as it is decelerating, descending downwards, the entire mass is now shifted towards the top of the lift. This is happening because acceleration is now becoming greater than mg. Till it was less than mg, it will stay at the bottom. And see now what happened. So this will happen to the lift and the object case. If we can decrease the value of the acceleration, let's see into it here. So as we have measured, then we can see the effect here. So already it is being attracting towards Earth with the help of gravity. So we can just make it less accelerated. See, now it is slowly rising, see, and reaching the top. Okay, we can further decrease it. Let's see what happens if we want to keep it in air. Okay, 1, 2, 3, start. See. As long as the acceleration quantity is greater than the mg force, it will rise up towards the ceiling and stick to it. So with this quantitative value, see, it's still quantifiable, and let's decrease it further. Now, okay, even further. Very less acceleration. So now you can see it stick to the ground. But still, with a jerk, it will rise over the ceiling. So this is the lift experiment that we have done. Now we are going to see theoretically that how we can measure the height of the building and with respect to the time period and the acceleration given. So let's see. So now we want to find that how tall the building is. So we have deducted the acceleration values here. So how we have deducted? We have find that acceleration is equal to g times of mass of the scale divided by mass of the body minus 1. So in the previous video, we have found that the acceleration 1 value, we can reduce it with this equation, and we can just take g for now as 10 meters per second square. And then we can put the values here. So our initial weight was 60 kgs and its initial weight was 80 kgs. Okay. So 10 meters per second square, 60 by 80 minus 1. So this will come out as minus of 2.5 meters per second square. So this is the acceleration in downward direction, and acceleration 2 as 10 meters per second square. We can take 100 by 80 minus 1. And this is also come out to be minus of 2.5 meters per second square. These 60 and 100 are the apparent values that was coming when lift was going up and lift was coming down, that we have calculated in the last video. So now we can see, we can find the distance d1. So we can use that d1 as, for how much seconds we have to find. We want to find t1 for 2 seconds, and we want to find it for the distance with the help of s is equal to ut plus half at square equation. So by the equation we have s is equal to ut plus half of at square. At time initial velocity being 0 and acceleration being g, we can calculate the d1 distance for t is equal to 2 seconds to 4 seconds, which is the delta t part. We can say that half of at square value in delta t1 square value will come out to be half of 2.5 multiplied by 2 seconds. So this will result nothing but the 5 meter distance that d1 covered. Now for the second part, we want to find the d2 value. So at delta t2 values, we can get at when v was 5 meters per second, we can get as d2, that second part, as v delta t2. So we will find that it's v, that is 5 meters per second, times delta t2 would be 22 minus 4, which would be 18 seconds. 18 meter. Just a second. So that would be 5 meters per second multiplied by 18. So that would be 90 meter. Weird. Okay. How we got the v? V was predicted by the formula v is equal to u plus 80. So u was initially 0 and a was 2.5 multiplied by 2 seconds. So you can take the positive value here. So that is 5 meters per second, the velocity. Alright. Now for the rest of the part, we can also calculate for d3 value, which is nothing but against v delta t part. So v delta t3 at the time interval minus half of a t, so t square. So this is nothing, just we can calculate 5 into 2 meters per second. 5 meters per second into 2 multiply by minus of half of 2.5 multiplied by 2 squares. So it would be 10 minus 5, which would be 5 meter. Clubbing all of them, we can add d1, d2 and d3 part. So total distance will come out to be d1 plus d2 plus d3, and that will come out to be 5 meters plus 90 meters plus 5 meters. So how tall is the building that we have found out? That would be 100 meters is the length. So we can go on to the option C would be the correct answer. Thank you.